Light. Learning objectives. Light. The speed of light. Light rays. Reflection of light. Mirror. Effect of light on plants. Lenses. Spectrum. Light. Light is a form of energy. It is essential to things visible around us. In the absence of light, we cannot see things, no matter how big or near they are to us. We, then, use our sense of touch to locate things or find our way. Suppose you are sitting in a well-lit room at night. Suddenly the light goes off. You or your elders search for a candle and matchbox by feeling through their hands, trying to locate it in the darkness. Similarly, when we enter a dark cinema hall, we immediately are unable to see and locate our seat. But we can do so later. Light is needed for almost all our day-to-day activities. One of its most important uses of lights to manufacture food production in green plants in its presence. 6CO2 plus 6H2O C6H12O6 plus 6O2 carbon dioxide, water, glucose, oxygen, photosynthesis reaction. Think of other important uses of light. Although light itself is invisible, yet its effect can be realized due to its visual effects. The speed of light. Earlier, people used to believe that light travels from one place to another instantly. But, actually, light takes some time to travel from one place to another. But it travels very fast. The speed of light in vacuum is 299,792 km per second. But, for practical purposes, it is taken as 3 times 108 meters per second or 3 times 105 kilometers per second or 3 lakhs kilometers per second in air. It takes about 8 1/4 minutes for light to reach the Earth from the Sun. This is because the distance of the Earth from the Sun is 148.5 million kilometers. It takes several years for light to travel from the stars to the Earth. Some stars are so far off that light from them takes millions of years to reach the Earth. Sci facts. The first precise measurement of speed of light was done by an American physicist, Albert A. Michelson, in 1926. Rectilinear propagation of light. Light travels in a straight line. You can observe sunlight falling on the ground in a straight line. Also, when you switch on a torch, you can see the light focused on the object. The dust particles, which come in the way or path of light, also get lightened. When you go to see a film in a cinema hall, you see the light falling on the screen. The rays of light from the projector there travel in a straight line. Laser beams are also used in entertainment shows that you would have seen on your television screens. These days, small laser torches are used as pointers. All these show that light travels in a straight line. Let us perform some activity to study that light travels in a straight line. Activity 13.1. Take 3 square pieces of cardboard and pierce a hole in the center of each with a knitting needle. The holes in the 3 cardboards should be exactly at the same level. Make them stand on the tabletop at some distance from each other. Give some support at the base. Light a candle and place it on the table such that its flame and the holes in the pieces of cardboards are at the same level, i.e., in a straight line. Now observe the flame through the hole from other side of the last piece of the cardboard. The candle flame is clearly visible. This shows that the light travels in a straight line. Make a change in one of the piece of cardboard either by making a new hole and sealing the earlier hole by clay or wax, or by adjusting one of the pieces of cardboard slightly away from the center. Now repeat the process. Light rays. 1. Rays of light. The straight line along which the light travels is called a ray of light. 2. A beam of rays. A collection of rays is called a beam of rays. A. Parallel beam. The collection of rays traveling parallel to each other is called a parallel beam of light. B. Convergent beam. When the rays of light coming together meet at a point, they are called convergent beam. C. Divergent beam. When a collection of light rays, starting from a point, propagates in various directions, it is called a divergent beam. A. A ray of light. B. A parallel beam. C. A convergent beam. D. A divergent beam. A source spreads light in all directions. Luminous bodies such as an electric bulb, a burning candle, etc., spread light in all directions. The rate of flow of visible radiation is called luminous flux. The greater the amount of light emitted per second per unit area by a source, the greater is its luminous intensity. A luminous body gives light in all directions. What happens to light when it falls on any object? 1. The objects may allow the light rays to pass through them completely, such as in a transparent glass pane, glass sheet, etc. 2. The object may not allow the light rays to pass through it by absorbing and cutting off the light rays, such as in a wooden door. 3. The object may reflect the light ray incident on it, such as in a polished surface, a nickel-coated car bumper, etc. Let us study the following phenomenon. The reflection of light from a plane mirror has been shown in figure. In this figure, 3 parallel rays of light called incident rays are falling on a plane mirror at an angle to its surface. The plane mirror reflects the 3 parallel rays of light and sends them in another direction. The 3 reflected rays of light are also parallel to one another and they make the same angle with the mirror surface as the incident light rays. Reflection of light. You have read about that. When the light falls on an object, it may pass through or may be absorbed or get reflected. If the light falls on a surface and is sent back or reflected, it is called reflection of light. The ray of light which falls on an object, say, a mirror, is incident ray, and the light which is sent back by an object, like mirror, is called reflected ray. 1. Reflection of light by uneven surfaces. When a beam of light is incident on a rough or uneven or irregular surface, the light rays get reflected in all directions, i.e., they are scattered in a wide area. Such a reflection is called irregular reflection or diffuse reflection. Due to this type of reflection, we see the various objects around us. A mirror that has an uneven surface does not give a clear image. 2. Reflection of light by smooth surfaces. When a parallel beam of light is incident on a smooth surface, a plain and highly polished surface, the reflected beam will also be parallel and, hence, the whole light falling on the surface is reflected in a definite direction. Such a reflection is called regular reflection. A mirror having a smooth surface gives a clear image due to regular reflection. The reflection of light from the smooth surface of water in the lake is producing an image of mountain, trees, clouds and sky in the water of. Laws of reflection. Learn the following terms before understanding the laws of reflection. I. The incident ray, the ray of light from a source striking a surface. 2. The point of incidence, the point at which the incident ray strikes the surface. 3. Normal at the point of incident, a line perpendicular to the point of incidence at the surface of a plane mirror at which the incident ray falls. 4. Angle of incidence, an angle between the normal and the incident ray. V. Angle of reflection, an angle between the normal and the reflected ray. There are 2 laws of reflection. 1. The angle of incident is always equal to angle of reflection. 2. The incident ray, the reflected ray and the normal at the point of incident, all lie in the same plane. These rules are always true for the reflection of light and are called the laws of reflection. Remember that the angle of incidence, an angle I, is equal to angle of reflection, an angle R. Activity 13.2. Fix a white sheet of paper on a drawing board with thumb pins. Draw a straight line up on the paper. Place the mirror strip over it, in standing position. Fix 2 paper pins at points P and Q and observe it from the different angles from the same side and fix pins at R and S. Remove the mirror and pins. Draw the lines PO, OS and the normal to the mirror. Measure the angle of incidence and angle PO and angle of reflection and angle SUN in degrees. Here the ray PO is an incident ray. The angle between the incident ray and the normal is called angle of incidence, i.e., an angle I, or an angle PO. The ray OS is the reflected ray. The angle between the reflected ray and the normal is called angle of reflection I.T. An angle R, or an angle SUN. On is the normal line or simply normal. Activity 13.3. Take a plane mirror and keep it on a table facing upward. Take a pencil torch and switch it on. Shine it on the mirror from the right side. What do you observe? You will observe that the direction of the reflected light is towards the left side of the mirror. The plane of incidence, normal to the plane and reflected rays are in the same plane. Move the lighted torch from right side to some other direction, in such a way that the angle of incidence does not change. What do you observe? You will observe that the reflected ray has now moved to some other direction. But the incident ray, the normal at the point of incidence and the reflected ray are in the same plane, which is different than the earlier plane of incidence. The laws of reflection in a plane mirror are the same as in spherical mirrors. Unit of light. Lux, Lx, is basically the unit of light or illumination and is equal to 1 lumen per square meter. 1 lux equals 0.0929 foot candles and this is the metric equivalent of foot candles. Notable, SI prefixes can also be used where 1 kilolux, KLX, is equal to 1000 lux. Psi facts. A foot candle is a non-SI unit of illuminance or light intensity. The foot candle is defined as 1 lumen per square foot. Mirror. Mirror is a sheet of glass silvered on one side. A coat of dark paint is done to protect the silvering. Thus, no light can pass through the mirror. An ideal mirror should have the following features. I. There should be little or no transmission. 2. It should not absorb light. 3. It should reflect to the best and give maximum reflection. This is achieved by A. A smooth surface for a clear image. That is why a glass sheet is used in a mirror. B. A shiny surface for reducing transmission. That is why a silvering layer is applied to the mirror. C. A red paint for protecting the silver coat. Image formed by a plane mirror. The image of an object formed by a plane mirror is 1. Laterally inverted. 2. Of the same size as the object and erect. 3. Virtual. 1. Image is laterally inverted. Activity 13.4. Look at your image in the mirror. When you touch the left side of your chest with your right hand, the image shows the touching of the right side with right hand. Thus, it appears that left appears right. Thus, the image formed by a plane mirror is laterally inverted. 2. Images of same size and erect. In a plane mirror, the image formed is of the same size as the object. The image is also erect. Examples. I. The top does not become bottom in the image. The size of the image is also the same. 2. If we move close to the mirror, the image also moves closer. And if we move away from the mirror, the image also moves away. 3. Image is virtual. In a plane mirror, a virtual image of an object is formed. A virtual image cannot be formed on a screen placed behind the mirror. An image which can be obtained on the screen is called a real image. Uses of plane mirror in daily life. 1. Mirror is used to dress up at home. 2. It is used in hair-cutting salons, shops, etc. 3. It is also used for decoration in shops. 4. To maintain the standard distance of the chart required for testing the eyesight. 5. They are also used in many gadgets and optical instruments. Sci facts. A device used to see distant objects like stars, planets, etc. is called telescope. J. Kepler invented it in the year 1611. Multiple images. If you keep two mirrors inclined at an angle, they can form multiple images. This is because the image formed in one mirror serves as the object for the other mirror. Activity 13.5. Take a white sheet of paper and fix it on a table with drawing pins. Draw two lines inclined at an angle of 60 degrees to each other. Now, take two plane mirrors and place them on the two lines in such a way that their vertical edges touch each other at the vertex of the angle. Place a 1 rupee coin in between the space left by the two mirrors. Look into the mirrors and count the images. What do you observe? You will observe that there are many, about 5, images. You can change the angle between the mirrors and then note the changes of the number of images formed. Kaleidoscope. A kaleidoscope is a device that works on the principle of multiple reflections in inclined mirrors. A kaleidoscope consists of 3 plane mirrors arranged at an angle of 60 degrees to each other in a cylindrical tube having colored glass at one of its ends. If you view from the other end, you will see multiple design images of glass pieces formed by the mirror. Periscope. A periscope can be used to observe over, around or through an object, obstacle or condition that prevents direct line of sight observation from an observer's current position. It consists of 2 plane mirrors. Let us make a periscope. Take a cardboard box and cut slits at 45 degrees angle in both of its sides. Insert a small mirror in each slit. As shown in figure, the reflecting sides of 2 mirrors must face each other. Cut peepholes opposite to the reflecting sides of the 2 mirrors. Cover the ends with black paper or plastic. Fix it with rubber bands or tape. The periscope is ready. Spherical mirrors. A spherical mirror is a part of a spherical surface which is capable of reflecting light. There are 2 types of spherical mirrors. 1. Concave mirror. When the reflecting surface is curved inwards, the mirror is called concave mirror. It is like the inner side of the spoon. 2. Convex mirror. When the reflecting surface is curved outwardly, the mirror is called convex mirror. It is like the outer side of the spoon. Terms related to spherical mirrors. 1. Center of curvature. It is the center of the sphere of which the mirror is a small part. It is represented by C. 2. Radius of curvature. It is the radius of the sphere which the mirror forms the part. It is the line joining any point on the periphery with the center of curvature of the mirror. It is represented by R. 3. Pole. It is the center of the reflecting surface of a spherical mirror. It is represented by O or P. 4. Principal axis. It is the line passing through the pole and the center of curvature of a spherical mirror. 5. Principal focus. It is represented by F. F of a concave mirror. The light rays parallel to the principal axis and incident to a concave mirror meet at a certain point or converge to a point after reflection from the mirror. This point is called the principal focus of the concave mirror. F of a convex mirror. The light rays parallel to the principal axis and incident to a convex mirror appear to come or diverge from a point behind the mirror after reflection. This point is called the principal focus of the convex mirror. 6. Focal length, f. It is the distance between the pole and the focus of the mirror. It is always half the radius of curvature. F equals ROR equals 2f. Use of convex mirrors in our daily life. Convex mirrors are used as rearview mirrors in vehicles like cars, scooters, buses, trucks, etc. By looking at the rearview mirror, the driver is aware of the traffic behind his vehicle. Sci facts. The first telescope made by Sir Isaac Newton was of concave mirror. Effect of light on plants. You are aware that light is one of the most essential factors required for our survival. It is essential for plants to perform photosynthesis. Through the process of photosynthesis, plants manufacture their food and produce oxygen utilizing CO2. An optimum amount of light is required by plants to carry on photosynthesis. If the intensity of light is less than the required amount, the rate of photosynthesis may be reduced or it may suspend it completely. This is why there is no photosynthesis during night, since there is no light available to plants for the process. Different plants require different amounts of light during day. The minimum amount of time in a day that a plant requires light is known as its critical period. This critical period varies in different species of a plant. For some plant species, it is 14 hours, while, for others, it may be less. Some plants also show movement towards light. For example, you may have seen the sunflower bending towards the direction of the sun through the day. This is known as phototaxis. Lenses. A transparent medium, having two surfaces of which at least one is spherical, is called a lens. Like mirrors, lenses, too, are of two main types: convex or converging lenses, and concave or diverging lenses. Convex lens. A lens which is thick in the middle and thinner at its edges is called a convex or converging lens. It is also known as a converging lens since it bends a light ray passing through it inwards. Thus, when some parallel light rays are made to pass through a convex lens, it makes them converge at a single point, called focus. Concave lens. A concave lens is thin in the middle and thicker at its edges. It bends a light ray passing through it outwards. When some parallel light rays are made to pass through a concave lens, the lens makes them diverge or spread out. The divergence of rays takes place in a way that they appear emanating from a single point behind the lens. This point is termed focus of the lens. Terms related to lenses. Principal axis. A lens is essentially a part of two imaginary spheres. The line C1, C2 which joins the centers of these two spheres is called the principal axis of the lens. Principal axis of a lens. Optical center. You may observe that the central portion of a lens, whether convex or concave, can be considered as a glass slab. This is why a ray passing through the center, O, of a lens is not deviated. It only undergoes a little displacement which is too small to be counted. So, the optical center of a lens is a point on its principal axis such that a ray passing through it does not undergo any deviation. Focus. You have read above that the light rays parallel to the principal axis, when passed through a convex lens, converge at a single point. This point is called the principal focus or only focus, f, of the lens, convex or converging lens. Focal length. The distance between the optical center, O, and the focus, f, is called the focus length, f, of a lens. Image formation by a convex lens. When we place an object at a distance greater than the focal length of a convex lens, an image of the object is formed on the screen which is placed at the other side of the lens. In a dark room, fix a candle on a table and light it. Place a screen, a paper sheet, before the candle. Now place a convex lens in between the candle and the screen. Adjust the position of the lens so that a clear image of the candle appears on the sheet. The image formed by a convex lens is real and inverted. Images formed by a convex lens with the change in position of the object with respect to the lens, changes also happen in the image formed. The various kinds of images formed can be shown with the help of ray diagrams as shown below. 1. When the object is very far off, at infinity, the image formed is formed at f2. Real. Diminished in size. Inverted. 2. When the object is at 2f, the image formed is at 2f. Real. The same size as the object. Inverted. 3. When the object is between f1 and 2f1, the image formed is beyond 2f2. Real. Magnified. Inverted. 4. When the object is at f, the image formed is at infinity. Real. Magnified. Inverted. 5. When the object is placed between f1 and O, the image formed is on the same side as the object. Virtual. Magnified. Erect. Image formed by a concave lens. A concave lens diverges all rays that fall on it. Therefore, for all positions of the object, the image formed is on the same sides as the object. Virtual. Diminished. Erect. Spectrum. You must have seen a rainbow in the sky. Have you noticed the beautiful color bands of a rainbow? If yes, you must have observed that it contains 7 different colors in a definite sequence or order. Have you ever wondered as to where do these colors come from? In fact, all colors find their origin from the sunlight. Isaac Newton, the great German scientist of 17th century, was the first to demonstrate that the ordinary white light is composed of many thousands colors. There are some ways in which light can be split into its different colors. When we split light into its different colors, the colors fall into 7 distinct color bands, viz., violet, indigo, blue, green, yellow, orange and red, vibreur. The pattern formed by the 7 colors of light is called a spectrum. To substantiate his theory, Newton made a beam of light rays to pass through a prism in a dark room. The light beam, coming out of the prism, had split into the 7 different colors. A spectrum was observed on the screen which was kept behind the prism. Similar phenomenon takes place when a rainbow is formed. After an occurrence of rain, the sun shines again. Some tiny water droplets remain suspended in air and the sunlight gets split into its different colors. This is why a rainbow is seen generally after a rainfall. Prism spectrum. Keywords. Almanac. A book in which prediction of eclipses is mentioned. Concave mirror. The mirror in which the reflecting surface is curved inside like the inner surface. Convex mirror. The mirror in which the reflecting surface is curved outside like the outer surface. Crescent. An early stage of moon when it is not seen as a full disk but as an arc. Earth light. Sunlight reflected by the surface of the earth. Incident rays. The rays of light from a source striking a surface. Incandescent. A hot glowing filament of bulb is called incandescent. Lux. Modern unit of brightness of a given surface. Lateral inversion. The phenomena of left appearing right and vice versa in a plane mirror. Summary. Light is a form of energy. An object which has its own light is called as a source of light. Light travels in a straight line. Shadows are formed when light is blocked or stopped by opaque bodies. Light is absorbed or scattered by the objects. The phenomena of turning back the light in the same medium is called reflection of light. A mirror reflects most of the light falling on it. There are two laws of reflection. I. The angle of incidence is always equal to angle of reflection. 2. The incident ray, the reflected ray and the normal at the point of incidence, all lie in the same plane. In a plane mirror, an angle I equals an angle R, i.e., angle of incidence is equal to the angle of reflection. The image formed by a plane mirror is laterally inverted, of the same size as the object, and virtual. The laws of reflection are same in plane mirrors and spherical mirrors. Spherical mirrors have a focal point. The image produced by them can be smaller and larger than the object, or of the same size as the object. Concave mirrors are used by dentists and in optical instruments. Convex mirrors always form a smaller virtual image of the object,